We know that high polar in nature, that water molecule, it is having more electronegativity difference between hydrogen and oxygen. Most of the inorganic and some organic compounds are soluble in water, hence it is called as universal solvent. When one water molecule behaves as acid and the other behaves as a base, the water undergoes self-ionization and the reaction is called autoprotolysis. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Now I am starting up session 3 from the chapter Hydrogen. In the last session we have discussed about physical properties of dihydrogen, chemical properties of dihydrogen and uses of dihydrogen and some of the classification and what are hydrates we have seen. In this class we will see about water, physical properties and the chemical properties of water. Water, we know that like 2 molecules of hydrogen, 1 molecule of oxygen, how it will be prepared we have seen in the preparation part, and we also know that water will be existed in gaseous state, solid state and liquid state. But what will be the structure, how it will be formed, we will see now. Structure of water in gaseous state. Oxygen atom in water is sp3 hybridized, thus H2O is bent or V-shaped molecule. This structure already we have seen in chemical bonding and molecular structure. This 2H and O will be in center, but it is in bent structure due to the lone pair of electrons on oxygen. Water molecule has 2 OH bent structure of H2O, covalent bonds which are bent to an angle of 104.5 degree. This OH bond has been bent structure, see bent structure. This structure is possible only in the gaseous state because the molecules have no hydrogen bond repulsion of bonds of electrons by 2 ion pairs of electrons. This bent structure is only possible in gaseous state because here no hydrogen repulsion is there, only oxygen is there. So it is in bent structure. According to VSEPR theory, water molecule is polar with dipole moment of 1.84 dBi. According to valence shell electron pair repulsion theory, that water is a polar molecule or a polar solvent with the dipole moment of 1084 dBi. Next, in liquid state, water molecule is highly polar due to difference in the electronegativity between oxygen and hydrogen. Hence, the liquid water molecules forms hydrogen bonds between them. Hence, the boiling point of water is very high, that is 100 degrees Celsius. In the absence of hydrogen bonds, water molecule should have been gas molecule only. We know that high polar in nature, that water molecule, it is having more electronegativity difference between hydrogen and oxygen. So what it will happen? It will form hydrogen bonds between them, and that's why the boiling point of water is 100 degrees Celsius. Whenever the absence of hydrogen bonds will observed, that time it will be in the gaseous state only. Next, in solid state, when water freezes to form ice, it gets oxygen atom is bonded to 2 hydrogen atoms by 2 covalent bonds. It also forms 2 hydrogen bonds with 2 hydrogen atoms of neighboring molecules. Hence, ice has a 3-dimensional crystal lattice in which oxygen atoms are surrounded by tetrahedrally by 4 hydrogen atoms, and each hydrogen atom is bonded of 2 oxygen atoms forming 1 covalent bond and 1 hydrogen bond. See, this is water molecule usually means what it will be tetrahedrally, another oxygen, here another oxygen, here hydrogen, like 3-dimensional picture we can observe when it freezes to ice. The water molecules of ice are joined by hydrogen bonds to form against 3-dimensional cage-like structure which has large vacant space. Hence, the volume of ice larger than water and hence is lighter than water also. In the 3-dimensional picture, in between so many spaces are there, hollow spaces. So what will happen? Ice is lighter than water. Water has maximum density at 4 degrees Celsius. From 0 to 4 degree density increases because volume decreases due to breaking up of hydrogen bonds. Above 4 degree, thermal expansion becomes greater than contraction in volume due to breaking up of hydrogen bonding. After 4 degree Celsius, what will happen? The thermal expansion will occur. So, the breaking up of hydrogen bonds will happen. The contraction contraction in volume due to the breaking up of hydrogen bonds. We can see above 4 degree Celsius. This is about the water in 3 states of matter. Next, physical properties of water. Hydrogen bonds present in water. Water molecule is polar and these molecules of water are held by hydrogen bond. Hence, water has an abnormally high boiling point of 100 degrees Celsius when compared to hydrates of other elements group 16 like H2S and H2SE. Molecule is held by hydrogen bond. It is having 100 degrees Celsius, the high boiling point, but hydrates of elements only, it doesn't have that much boiling point. Solvent behavior. Most of the inorganic and some organic compounds are soluble in water, hence it is called as universal solvent. Solvent behavior means the solute should get dissolved in solvent. In the water, usually most of the organic compound, most of the inorganic compounds will get dissolved. So, water will be usually called as universal solvent. Water has high heat of fusion and high heat of vaporization. This high heat of vaporization, high specific heat and high thermal conductivity due to polar nature. Due to the polar nature, it is having high heat of fusion, high heat of vaporization and also high thermal conductivity is present. Next, chemical properties. Electrolysis. Water is stable liquid with abnormally high boiling point of 100 degrees Celsius. It is not decomposed by heating at even high temperatures. However, an electric current passed through water can decompose it to form hydrogen atom at the cathode and oxygen at anode. When water gets electrolysis, means the lysis of water molecule, the H2 and O2 will form, but the hydrogen will be at cathode, oxygen is at anode. This is about electrolysis of water. Next, amphoteric behavior. Water can act as weak acid as well as weak base. Amphoteric means it can act any solvent like act acid and also base. Water, we know that it is a neutral solvent. Here the water is acting as acid means ammonia, it's a base. What will happen? NH4 will act as acid and also OH minus base. Here if water is acting as base with the acid H2S, H3O plus, that is acid, and HS minus, it's a base. So it shows that water is a neutral solvent which can act as acid as well as base. Next, hydrolysis. Salts react with water to form corresponding acids and bases in this reaction called hydrolysis. This is ferric chloride, solid salt. In the presence of water, ferric hydroxide will form and HCl will also form. Whenever salts react with water to form corresponding acids and bases. Due to this water molecule, it will form an acid as well as base. Next, redox reaction. Water acts as an reducing agent when it reacts with sodium to form sodium hydroxide. Sodium, we know, it will, in the presence of oxygen, it will be catches fire. So sodium is treated with water means water will act as a reducing agent. So this sodium will get reduced for sodium hydroxide and H2 gas will be liberated. And water is also act as oxidizing agent when it reacts with fluorine to form hydrogen fluoride. See, fluorine, water, it will form hydrogen fluoride. It gets oxidized here. It is reduced. So it will be act as oxidizing agent. Next, autoprotolysis or self-ionization. When one water molecule behaves as acid and the other behaves as a base, the water undergoes self-ionization and the reaction is called autoprotolysis. Auto means self. Here water is reacting with another water molecule, but one water molecule should act as acid and another water molecule should act as base. That time it will be created or it will be act as ionization. So what will form? Conjugate acid and conjugate base will form. Next, hardness of water. Certain salts can cause hardness to water. Hard water cannot produce lather readily with soap, but soft water gives lather readily with soap. Lather means foam. Hard water is formed due to some presence of salt in the water. It does not form any foam or lather with the soap. But soft water, which is absence of salt, it will form lather or foam with water. Causes of hardness of water. Hardness of water is due to the dissolved bicarbonates, chlorides and sulfates of magnesium and calcium. Okay, magnesium and calcium, bicarbonates, chlorides and sulfates, it will cause us hardness. There are two types of hardness, that is temporary hardness and permanent hardness. First we will see temporary hardness. It is due to the presence of calcium and magnesium bicarbonates in water. Whenever the bicarbonates of calcium, magnesium are present in the water, that will be leads to temporary hardness. Temporary hardness can be removed by boiling hard water or by adding slaked lime to hard water. It can be removed also because it is temporary, right? It will be removed by boiling or by adding slaked lime. How it will be removed, we will see. The methods used to remove temporary hardness are by boiling. When hard water containing bicarbonates of calcium and magnesium bicarbonate converts into insoluble magnesium hydroxide and calcium bicarbonate converts into insoluble calcium carbonate. See, this is magnesium bicarbonate, boiling, magnesium hydroxide and carbon dioxide will be liberated. That is insoluble magnesium hydroxide, and this is calcium bicarbonate, boiling, calcium carbonate will form and also carbon dioxide with water. This is how it will be removed. Next, Clark's process. In this method, calculated amount of lime is added to hard water to convert calcium bicarbonate into calcium carbonate and magnesium bicarbonate into magnesium hydroxide. This is calcium bicarbonate will be treated with calcium hydroxide, that is nothing but slaked lime, and calcium carbonate will be formed with water molecule. This is magnesium bicarbonate. This is also treated with slaked lime and magnesium hydroxide and calcium carbonate and also water molecule will be formed. These are the two methods by which the removal of temporary hardness can be seen. First one boiling and next one is Clark's process. Next, permanent hardness. It is due to chlorides and sulfates of calcium and magnesium. It can be removed by addition of sodium carbonate. By chlorides and sulfides of calcium and magnesium, the permanent hardness of water can be caused. How it will be removed? By adding washing soda or sodium carbonate, they have told. Magnesium chloride, next sodium carbonate, magnesium chloride is treating with sodium carbonate. Magnesium carbonate will form with sodium chloride salt. And calcium sulfate with sodium carbonate, that is washing soda, calcium carbonate and sodium sulfate will be formed. When hard water containing chlorides and sulfates of magnesium and calcium gets converted into magnesium carbonate and calcium carbonate precipitate, which then filtered off. These are all precipitates and it will be filtered off. Next, Calgons method. In this method, the hard water is treated with sodium hexametaphosphate to render the ions, as the compound forms soluble complex with calcium and magnesium which do not interfere in the lather formation itself. Whatever the magnesium and calcium will form, in that process the ions will not involved in the lather formation, which will be removed by sodium hexametaphosphate. The trade name of sodium hexametaphosphate is Calgon, which means calcium gone. Thus the process is called Calgon's process. See, this is hexaphosphate, sodium hexa, metaphosphate, and here sodium ions, it will be rendered and that metal ion will be surrendered here and it will form calcium, Calgon process. Next, ion exchange method. Zeolite, hydrated aluminium silicate, is added to hard water, exchange reaction takes place. See here NaZ plus metal, Mz2 and sodium will be removed. Zeolite is generated by treating with an aqueous sodium chloride, Mz2 plus sodium chloride, aqueous sodium chloride, NaZ and MCl2 will form, metal chloride. Synthetic resin method. Synthetic cation exchange resin containing organic molecule with sulfate group and alkyl sulfate is converted into RNA, that alkyl sodium by treated with sodium chloride. It is Treated with hard water, the resin exchange of sodium with magnesium or calcium which makes water soft, that is R is resin anion. Here the R is resin anion. Here resin metal, that alkali metal treated with M2 plus, it will form resin metal and sodium. Resin can be regenerated by adding aqueous sodium chloride. By sodium chloride only it will be removed. If we add, it will be come back. So these are the so many chemical properties of water, and the how temporary hardness, what is temporary hardness, what is permanent hardness we have seen, and what are the methods to remove both the hardness of water also we have discussed. In the next class, next session, we will discuss about hydrogen peroxide, preparation of hydrogen peroxide, physical and chemical properties and heavy water. I hope you have understood whatever I have taught today. So, we will meet in the next session. Thank you.